Welcome to the second and last part on this topic, preparation of salts. So far we've looked at some terminologies. Then we looked at preparation of salts part 1, where we discussed two methods, synthesis and replacement or decomposition. Here we're going to start two other methods in preparation of salts part 2. So we're going to start with the third method, precipitation. What is precipitation? Before actually we can define it in this context where we're talking about preparation of salts, you remember that when we were studying separation techniques, we talked about, actually not separation techniques, but solutions. We talked about a precipitate being an insoluble solute in a solvent or a cloud mixture of a solvent and a solute. So that's the basic concept of precipitation. So precipitation is the formation of an insoluble product and may occur on mixing two solutions. So it is used to prepare insoluble salts. So whenever you've been tasked with preparation of insoluble salts, you use precipitation. So it is also called double decomposition, or it's a type of double decomposition. Remember, we talked about replacement or decomposition, where one element replaces the other in the solution. For example, if you want to prepare a salt, let's say sodium chloride, you just get sodium and hydrochloric acid. Since hydrogen on hydrochloric acid is lower on the reactivity series than sodium, so sodium is going to replace the hydrogen in hydrochloric acid. That was replacement or decomposition. But precipitation is a double decomposition where there is some kind of replacement happening twice. So in double decomposition, two solutions are mixed to form an insoluble salt and a soluble solution. To give more insight into what double decomposition is and what precipitation is, we can specifically say that precipitation is like this. We have a soluble salt reacting with another soluble salt to form an insoluble salt and a soluble salt. So I'm going to explain well when we look at an example how double decomposition happens here. But double decomposition in general is like this. We have a soluble solution mixing with another soluble solution to form an insoluble solid and a soluble solution. So as you can see, the soluble salt here is, of course, the soluble solution. Soluble salt, of course, we assume, or usually, it is a salt that has already been dissolved in water for this reaction to be possible. So it is representing the soluble solution. The other soluble salt, also soluble solution. The insoluble salt, of course, the insoluble solid. And finally, the soluble salt that is formed represents the third soluble solution because it will be already dissolved in water or into something, of course. With that being said, we're going to take a look at one example where we're going to prepare silver chloride. Remember, silver chloride is insoluble. So when you have been tasked or when you have been asked to prepare silver chloride, the first thing you have to ask yourself is silver chloride soluble or insoluble? So definitely silver chloride is insoluble. Therefore, you can use precipitation. The next job is to look at the reactants. What two reactants can you use to form silver chloride? Those two reactants must be salts which are soluble. Salts which are soluble, so that when you dissolve them in water, then you mix them. They should be able to form this insoluble silver chloride. So they have to be very soluble so that they dissolve in water so that the reaction happens. So let's think of two soluble salts that one should have silver, the other one should have chloride. Remember, all nitrates are soluble. So if we use silver nitrate, then we are good to go because silver nitrate is soluble and it has silver. Then of course, what can we use which has chlorine? We can use sodium chloride. Sodium chloride has chlorine, so we can use it. So the reactants are silver nitrate, which is very soluble, and sodium chloride, which is also very soluble. Of course, even hydrochloric acid can work. With that being said, we can be assured that the product are going to be silver chloride with the one we're looking for and sodium nitrate. How so? let's take a look at the equation. So we have silver nitrate reacting with sodium chloride. So here is where double decomposition happens. So what's going to happen is silver is going to take the place of sodium. This is replacement or decomposition, and sodium is going to take the place of silver here. So double decomposition. Hope that one is going to sink in. So the end product, of course, is going to be silver combined with chlorine and sodium combined with nitrate. So we're going to have silver chloride and sodium nitrate as the product. So sodium chloride, of course, it's insoluble. So imagine this situation: you mix two solutions. Let's say a salt solution and a sugar solution. You mix them. So you're going to, when you mix them, then you see some chalk or cloudy or insoluble solutes coming out. So it's like magic. You mix things that are not there, then when you mix them, some whitish thing come out. So the whitish thing is the precipitate, the silver chloride. Why is it coming out? Because something has been formed inside those inside the mixture, which does not dissolve in water. Okay, so it's going to appear in those in the mix. It's going to appear, it's going to come out as a cloud or as a chalky, whatever you can call it. So it's a suspension or a precipitate. So that's what happens in precipitation. You mix two solutions which don't have anything which you can see with your eyes because the things are dissolved inside. Then what you're going to get is an insoluble substance coming out of it, a precipitate, and of course we're going to have another solution which is of course going to have a soluble salt. So now that we have this thing, a mixture that has the insoluble salt and the soluble salt, how do we separate the two? So let's take a look at the steps that are done for this silver chloride to be prepared. So this is the ionic equation: silver ion reacting with chloride ion to form silver chloride. So the first step that you do is you mix silver nitrate solution with sodium chloride solution in a beaker. So get your beaker, you put the silver nitrate, which looks as pure as this. Then you can also put sodium chloride, which is as pure as that. So the two are going to react and you are going to have a chalky or a suspension or a precipitate like that. So once that is done, you have to allow the precipitate to settle. So we're going to do sedimentation and decantation, where we're going to allow this to settle, and when it settles, we're going to we can pour out the liquid on top. But when we do that also, we can get a filter paper where we can pour everything so that the insoluble substance remains on the filter paper. So that is the next step. You filter off the precipitate and wash it with distilled water to remove any amount of sodium nitrate left. Remember, the sodium nitrate is the soluble salt that is also a product. So when you get your filter paper, of course we're going to have this beaker, we're going to have this sodium nitrate which we don't want. You have to get a filter paper, put it here, then you pour the mixture here. So the sodium nitrate is going to pass here, then the salt that we have prepared is going to be here. The silver chloride is going to be here. So once of this salt, it can be wet, of course, meaning that it has a bit of sodium nitrate. So what we have to do is we have to dry the salt. That's the only way we can get the pure salt. So that step is to dry the precipitate on the filter paper. So these steps, allowing the precipitate to settle, filtering off and drying, are the last step of this process. Otherwise, the first step is just to mix the two mixtures. So we cruise to, before we can cruise to the last method, let's take a look at another example. It's going to be a quick one. How do we prepare lead to chloride? So lead to chloride, of course, it is an insoluble salt. So we have to think of reagents. So we need something that is soluble. Again, I'll use the same kind of thinking. I'll use the lead nitrate because any nitrate salt is soluble. And chloride, I can use again sodium chloride. So the reagents are lead 2 nitrate and sodium chloride. Of course, again, hydrochloric acid can work. So the product is of course lead 2 chloride and sodium nitrate. If you're not sure of how to get the product, just write the equation. So here you're going to do double decomposition. This is going to take the place of sodium, so you're going to have lead chloride, and sodium is going to take the place of lead. You're going to have sodium nitrate. So I have lead chloride and sodium nitrate. And of course, the ionic equation is this. So go to the last method, neutralization. So we know what neutralization is, where an acid reacts with a base to form salt and water. So there are three different ways in which we can form a salt using neutralization. The first is where a metal hydroxide, which is of course a base, reacts with a dilute acid. The reaction of a base and an acid, of course, is called neutralization, as we know. The second one is where an insoluble metal oxide reacts with an acid, with a dilute acid, of course. So an insoluble metal oxide, it is what kind of oxide? Is it a basic oxide, amphoteric oxide, neutral oxide, or what's the acidic oxide? Yes. So usually insoluble metal oxides are basic oxides. So these behave like bases. If you can remember on types of oxides, these react with acids to form salt and water. So even this, you can use neutralization. The third is where I use a metal carbonate with a dilute acid. Remember the properties of metal carbonate. So metal carbonate usually reacts with dilute acid to form salt, water, and carbon dioxide. So this is another example of a neutralization method of preparing salts. So we're going to take a detailed look at one example, which is this one, the first one. These other two, we're going to just look at examples and the steps on how to prepare. But this one, I'm going to demonstrate how it is done. Why? Because this one usually comes as part of the practicals. With that being said, let's get started. So what we're trying to do is we're trying to mix a metal hydroxide with acid to form salt and water. So we're going to prepare sodium chloride. So we need a metal hydroxide that's going to give us sodium. We can say sodium hydroxide. And we need an acid that's going to give us chloride. We can say hydrochloric acid. So the reaction equation, of course, is sodium hydroxide reacting with hydrochloric acid for sodium chloride and water. So method of preparation. So there are two most important stages. The first stage is called the preliminary titration. So in preliminary titration, you do a titration to determine the amount of acid that is needed for the reaction to occur. Okay, so we use an indicator to determine the end point. The end point is a point where the reaction completes. I know it might be too hard to comprehend everything here, but I'll make sure that you get it at the end of the day. So don't worry about what this statement means. I will explain it in detail. So the first step is to use a pipette to measure 25 centimeter cubed of sodium hydroxide and you put it into a conical flask. What is a pipette? A pipette is just an instrument, a lab apparatus that is used to transfer liquids from one container to another. So of course, maybe at some point you'd be required to use a pipette to transfer a liquid. So maybe I demonstrate how to use a pipette. So what you do with a pipette is, the first step is you get your pipette. Okay, usually there are different types of pipettes, but in the labs that we usually use at school, we have this type which has got a bulb here. So this bulb, it's something that you can squeeze, not like a bulb, like a light bulb. No, it's like it's a rubber, something you can squeeze. So what you do is you put it here. When you do, you put your pipette in the liquid, in the container which has the liquid which you want to transfer to another container. So when you do that, you squeeze your pipette. So when you squeeze your pipette, water is going to be drawn up the pipette. So there are different types of pipettes with different volumes. So let's say this is a 25 centimeter cubed pipette. So the water that's going to be here is 25 centimeter cubed. Okay, that's the first step that you do. The other type of pipette which doesn't have the bulb here, you have to put your mouth here and you suck the liquid with your mouth. Okay, so once you have the liquid here, what you have to do is to remove the bulb and put your index finger, which is step 2. You put your index finger on top. So if you have removed your mouth, in case you're using your mouth, you have to put your index finger on top. Once you do that, you have to not necessary, but it's okay to wipe the bottom of the pipette, so that if there is any liquid that was dropping, you clean it so that it doesn't disturb the volumes that are going to be transferred. Then of course after that you can go to step 4. I just got this picture on the internet somewhere, so I don't know why they did step 4 here. Yeah, so step 4, sometimes you can find yourself that you have sucked more liquid than what was needed. So you can be removing your finger here so that part of the liquid drops a bit, so that you have the required amount of the liquid here. So once you do that, when you are sure of the amount of, or the volume, the volume that you want, you can go to the container. In this case, it's a conical flask which you are going to use. Then you can put your pipette and remove your index finger. So when you remove your index finger, of course the liquid is going to go into your conic flask. So the way pipettes are made is there's always going to be a bit of liquid remaining here, so no need to blow so that this liquid goes, because by design they are designed to offset, to have a bit of this liquid when you're sucking, so that even if it remains, it doesn't affect the volumes that are going to be transferred. So this is generally how to use the pipette. You suck the liquid, you put your index finger, you put in the liquid that you want. These are the most important steps. You put in the container that you want the liquid to be, then you remove your index finger. So the idea is when you remove the index finger, the liquid starts to pour. So that's how to use the pipette. Now let's go back to our experiment. So now maybe you can understand, using a pipette, measure 25 centimeters of sodium hydroxide. What this means is you have, let's say we have a conical flask here where we want to put our sodium hydroxide. Then we have a beaker here which has our sodium hydroxide. So we want to transfer this sodium hydroxide into this. So we get our pipette there, we suck the 25 centimeter cubed, this is 25 milliliters of cubic. So we suck. Once we suck, we transfer, we put our index finger, then we transfer to here. When we do that, then we remove the index finger, and then we pour the 25 centimeter cubed of sodium hydroxide here. So once that is done, you go to the next step, where you put the indicator. Remember, an indicator on acids and bases, an indicator is a substance that shows us the pH of a solution. So the indicator is going to tell us when the reaction has completed. How? Because this is a base, it has a pH greater than 7. So when we put an indicator, its color is going to be that of pH greater than 7. So when we will be adding the acid, these two are going to be reacting. When they form water and salt, which is neutral with a pH of 7, the indicator is going to show the color that is, of course, pH of 7. So add 2 or 3 drops of indicator to sodium hydroxide using a pipette. So again, you get a let's say this is the indicator. So you get a pipette, you get some indicators. This time you only allow just 2 or 3 drops to your sodium hydroxide solution. Once that is done, you fill the burette to the 0 reading with dilute hydrochloric acid. What's a burette? Of course, the burette is this. So this is the burette. This is another apparatus. This is used for the acid. So what you do is, the way the burette is, it's open here and it is also open here. Then here it has a knob which you can lock here so that no liquid goes down. and you can open so that the liquid comes out here. So what you do is you lock it. When you have locked it, you can pour your acid here up to when it is at 0. Okay, so that's how the burette works. So when you do this, when you fill the burette to the 0 reading with dilute hydrochloric acid, actually it is mostly done when the apparatus is set up like this. So there is a camp stand here, then we have your burette here, then we have your conic flask here with sodium hydroxide, and this one with your hydrochloric acid here. So once this is done, you have to make sure that your conic flask is on a white paper or white towel. Why? When the reaction starts and when we're observing, want to be able to observe the color change. You can do that, of course, when the background is white. You'll be able to see the color change well. So mark this volume or record this volume as V1. Then the next step is now to add diluted hydrochloric acid from the burette to sodium hydroxide in the conical flask, well swirling until the solution just changes color. So let me just say it now, not in Greek as it is, but in simple ways. So what you do is you open the knob here. So when you open the fluid, the liquid, the hydrochloric acid is going to start pouring into the base. So as that is happening, you have to hold the conical flask by the neck, then you start shaking it a bit so that the reaction, it should be happening here. So keep on doing that, observing the color change. At some point, the color is going to change. Once the color changes, it shows that the solution is now neutral. Okay, so when that happens, you have to close the knob here so that no more acid goes into your conic flask. So when that happens, of course, there will be a color change. So what you do is you record the second volume of the acid as V2. So what we're trying to do here, we're trying to determine the amount of acid that's going to react with 25 centimeter cubed of sodium hydroxide. So the amount of the acid, we get it by dividing the second volume, the first volume from the second volume. The first volume is 0. So whatever this is, we're going to get this number minus 0. What we get is the volume of acid that has been used. So now we know the exact volume of hydrochloric acid needed to react with 25 centimeter cubed of sodium hydroxide, and we get it by volume of acid is V plus V1. So hope you have gotten the thinking here. So when the color changed, it showed that the reaction was complete. Okay, that's why we stopped adding the acid, and the acid that has been used up is this here, V2 minus V1. So now go to the second and final step, which is the second titration, or the final type. By the way, this is called titration. The method is called titration. So here, in the second titration, what you do is of course, you have to clean everything. You restart. You get your conical flask. You put 25 centimeter of sodium hydroxide again. Then you go to your acid. You get the amount of acid that you have measured, VA. You put it in the burette. Then you add it to your base. This time we don't add an indicator because we know that this amount of acid is going to react with this completely. So we don't add an indicator. So the instruction are using a pipette, measure 25 centimeter cubed of sodium hydroxide and put it into the conical flask. So you have it in the conical flask here. Second, add a VA centimeter cubed of the acid from the burette sodium hydroxide. So from the burette here, you open till all this acid goes here. You shake to make sure that the reaction happens. Then now the next steps are very important. So this is a soluble salt. Neutralization is used to prepare a soluble salt. So once you have this mixture, how do you get the soluble salt? A soluble salt, you won't be able to see it as in precipitation. It is there but already dissolved. So how are you going to get it? The way to get it is you have to use evaporation or crystallization. How? You have to evaporate the mixture to obtain a saturated solution. Once that is done, you have to cool down the saturated solution to obtain sodium chloride crystals. This is the process of crystallization. You evaporate the mixture to get a saturated solution. Then you cool the saturated solution to obtain your salt crystals. Okay, so these steps are very important to get the dissolved salt. Finally, you can filter the mixture to obtain pure sodium chloride crystals. So remember, this saturated solution has the solvent part and of course the crystals. So the solvent part has to be removed by filtering. So you filter the mixture, and what you're going to have is your sodium chloride crystals. So we're done with titration. We go now to the second way of neutralization, the second method of preparing salts using neutralization. In the second method, we use an insoluble metal oxide and an acid, of course, which is going to give us salt and water. Insoluble metal oxide and an acid is going to give us salt and water. So for example, how do we prepare copper to copper 2 sulfate? So we need something that's going to give us copper, but it should not be soluble. It should be an insoluble metal oxide, like copper 2 oxide. Then of course, we need something that has sulfate, like sulfuric acid. So the reagents are copper 2 oxide, and sulfuric acid. Of course, dilute, not concentrated. So the reaction is copper 2 oxide reacts with sulfuric acid to form copper sulfate, and of course water, which is a salt and water. So the ionic equation is oxide ions reacts with 2 hydrogen ions to form water. So the steps to do this method of insoluble metal oxide reacting with acid are as follows. So we're going to use the preparation of copper 2 sulfate crystals. Of course, they have got 5 molecules of water of hydration, and we're going to show how they are prepared from copper 2 oxide and sulfuric acid. So first is you put dilute sulfuric acid in a beaker, then you warm the acid, but don't boil. Please don't boil, just warm it a bit. When you do that, you add an excess of copper 2 oxide. Remember, copper 2 oxide does not dissolve. So what's going to happen is you are adding, then the copper 2 oxide is going to be reacting with the acid. But you have to add it in excess so that all the acid is used up in the reaction. So you have to keep on adding till you see, if till they stop reacting, like you still see excess of copper 2 oxide, like you're adding but nothing is happening. Then when you do that, you have to filter off the excess copper 2 oxide. So what you're going to remain with is a blue solution of copper 2 sulfate. The copper 2 sulfate being what we're looking for. And this excess copper 2 oxide is the one we're adding just to make sure that all the acid is used up. Then finally, you have to evaporate the filtrate to obtain a saturated solution, because this solution of copper 2 sulfate is going to have our salt, copper 2 sulfate, inside the solution. Remember, neutralization is for soluble salts. So always when you are doing this method, you have to evaporate the filtrate to obtain a saturated solution. Then you have to cool the filtrate, in this case in an ice bath, to allow crystals of copper 2 sulfate to form. Then of course you can filter off the saturated the solvent of the saturated solution, so that you remain with your copper 2 sulfate. Finally, we take a look at the one which involves metal carbonate and an acid. So in this case, we have the reagents, which is magnesium carbonate in this case, and dilute sulfuric acid. So remember, we're going to get a salt, water, and carbon dioxide. We discussed this in acids and bases. So the reaction is magnesium carbonate reacts with sulfuric acid to form a salt, water, and carbon dioxide. And the ionic equation is this. Again, the steps are nearly the same. You put dilute sulfuric acid in a beaker, you warm the acid but don't boil. You add an excess of magnesium carbonate to the acid. You stir the mixture and filter to have a clear solution of magnesium sulfate. You evaporate, you cool. Same steps. So these are the preparation of salts. So precipitation for insoluble solids, insoluble salts. Neutralization, which of course titration, is for soluble salts. And the last steps of all the 3 different modes of neutralization, which is titration, and these other 2, which one involves the metal oxide, the other one involves the metal carbonate. They always involve they involve crystallization, where you get the crystals from the soluble salt which is in the solution. So you evaporate, you cool, you filter. So this marks the end of this topic. It has been a long one, 30 minutes. Anyway, hope you have learned a thing or two. Happy solving. Yako phone. Yako iliko. Ala, so zamani. Ni watu wa bwele. Iwe using sako yako zaitenga. Pangona, umatambali grace na tempa mini. Iwe